Hello everyone and welcome back to video lecture series on computer architecture. My name is Dr. Prashant Bachanna. In the previous video lectures, we have seen the first module, that is the introduction to the computer architecture, that is the different parts of the computer and the different instructions available in the computer architecture, that is assembly language instructions. Now in this video we'll be learning about the register transfer, that is the register transfer language, and register transfer for the bus and memory transfer. So before we begin our discussion to the register transfer language, so we'll see the importance of this. What is the register transfer language, or what are the importance of the register? So first we'll see what a register. So a register is a group of flip-flops. That is, the registers are made up of the flip-flops. Let us say if you say that register is of 8-bit, means it is made up of 8 flip-flops. So a flip-flop, each flip-flop is capable of storing 1 bit of information, and if we say like n bit of a register consists of a group of n flip-flops which are capable of storing n bits of information. So in addition to the flip-flops, the register may have combinational gates that perform the certain data processing tasks. So the flip-flops hold the binary information and gets determine how the information is transferred to the register. Then there are different types of registers which are available, that is the general purpose registers and the special purpose registers, which are used for both the applications. So the simplest register is one that consists of only one flip-flop without any gates. So in the computer architecture, so all the executions, like the executions performed by the processors are done with the help of the register. So that is why there's a lot of importance about this register. So whenever any, like the CPU or the processor executes any operation, a CPU or the CPU executes any operation, so all that executions will be done with the help of the registers. So that is the importance of these registers. Then we'll see the register that holds the address from the memory until it is called as memory address register. So the address which holds the memory is called as memory address register, and it is represented by MAR, or you can simply write it as address register. Then apart from that, we have these special purpose registers like program counter. So the program counter is usually 16-bit, which holds the address of next instruction to be executed. Then we have instruction register. So these are some of the special purpose registers in the computer architecture. The instruction register holds the instruction to be executed. So the CPU, whenever executing any operation, so it takes the operations to be performed as an instruction. So those instructions will be stored in the instruction register, and this R1 is for the processor register. So the individual flip-flops in any n-bit register are numbered in the sequence from 0 to n-1, and starting from the rightmost position and increasing the number towards the left. So the symbolic notation, it is used to describe the micro operations among the registers. So these are the symbolic representation of the instruction register as IARE. So which is used by the compiler. So for instruction register, IARE is the notation, and for program counter, PC is the notation which is used. So the term the register transfer can perform micro operations, and the transfer result from operation from the same. So in the whenever CPU executes any operation, it will execute with the help of the register. So this like the transfer of information from one register to the another register is called as register transfer, and this complete language we call it as register transfer language. So in the register transfer, so which performs a micro operation. So the micro operations, in the sense, the transfer of data or the information from one register to the another register, and the result will also be stored. That is what. So we have to remember some terms here. That is micro operations means the operation executed on the data stored in a register. Then they are called as micro operations, and they are detailed low level instructions which are used in some designs to implement the complex machine instructions. So this is about the micro operations. Then the register transfer, the information transferred from one register to the another register is represented in a symbolic operator, which is called as a register transfer. The term register transfer refers to the availability of the hardware logic circuit that can perform a given micro operation and transfer the result of the operation to the same or the another register. So most of the standard notations are used in this register transfer language. That is, for memory address register we use MAR, and for program counter we use PC, that is the program counter. It holds the address of the next instruction to be executed. And for the instruction register, IR is the notation which is used, and R1 is for the processor register. Then so we can also apart from like denoting PC like this, we can also represent the individual bits. PC is of 16 bits, so we can split the 16 bit into 8 bit and 8 bit, and we can say like this PC 8 to 15. So these are 8 bits, and like this we can and we can also say PC as 0 to 7. So since program counter is of 16 bits, so we can individual 8 bits at one time. So if you write PC 0 to 7 means it consists of the 8 bits from 0 to 7. Similarly, we can write it for the different other registers also. So based on the like individual bits also we can represent. Let us say like if we like take this an example of this. So the content, so this will represent the content of R1 is moved to R2. That is, R1 is the register, the content is moved to R2. So typically these like the users wants the transfer to occur only in a predetermined control condition. So in this case we can write like this also. So this complete language we call it as a register transfer language, wherein we use these notations to transfer the content from one register to the another register. And like if you write R1 this R2 arrow mark R2 is it will transfer the content from R1 to R2 without any condition. So if you want to put some condition, so let us say like we can write it as P. So let us take this an example. What is this register transfer language? So if you write P, so this instruction, that is this instruction of register transfer language, will transfer the content of R1 to R2 if the value of P equal to 1. So in the register transfer language we use different types of functions, so with condition and without condition, the content can be transferred from one register to the another register. So digital system, that is interconnecting of the digital hardware models that accomplish a specific information task. So all these things we that is the models constructed from such digital components as registers, decoders, arithmetical. And so the registers are the important part apart from the control logic, decoders, and arithmetic elements. So the operations performed on the data in the registers. So we call it as register transfer language, and the operations what we performed on these registers are called as the micro operations. So the general operations we perform on the registers in the computer architecture are like shift operations. There are different like shift operations are there, like a right shift, left shift operations, which are used for different applications. Then we use load operations, then the clear and the increments. So for all these operations, we use this register transfer language. Same thing what we have like the micro operations, that is in the register transfer language we use micro operations like this, which will do the operations. Let us say like here f is a function which will consist of the registers here. So it can do the different operations like shift, load, clear, increment, add, subtract, complement, and all. So the internal organization of a computer is defined as a set of registers and their functions generally, and the operations which we perform, we call it as the micro operations. That is, these micro operations will allow, like is provided by the organization of the computer for execution of the instructions. So the symbolic notation used to describe the micro operation, we call it as a register transfer language. So the processor, whenever processor, the CPU executes any operation, so the operations it will execute with the help of the registers, the two types of the registers, general and special purpose registers. So the symbolic notation used to transfer the content of the registers, content of register from one register to the another register, let us say for R1 to R2. So we call it as the register transfer language. So already we have seen these are the notations which are used for different things, and we have also seen this also. So this notation of the transferring the content from one register to another register, we call it as a register transfer language, RTL. So these are so this table shows the basic symbols of RTL, that is a register transfer language. So in this we have we'll see this is so this table shows the symbol. So donates this donates the part of the register. So this symbol will represent, let us say, like if I write okay, so first we'll see letters and numbers here, so we can represent directly the registers like this, R1, R2, and MER is a memory address register, and this if I write R1 bracket 8 bit. So when we write to use this, so this bracket is used for with donation the part of the register. So if you write R1 bracket 8 bit, it shows that the R1 is of 8 bit. So let us say if I write R1 0 to 7, so which will also represent, that is the R1 is a register which consists of the bits from 0 to 7. Then this arrow mark towards the left will indicate information from one register to the another register. So in the register transfer language, so these are the notations which are used. So let us say if I write R1 arrow mark R2, so which will represent that the information present in the register R1 is moved to the R2. Then if you want to specify two micro operations at the same time, so that can also be performed with the help of the comma. So let us say, like if I want to write two information, so R1 arrow R2, then we can write it as comma like this. So we can use this comma for this. So so apart from these two, apart from this, we have this symbol here. So like in the register transfer language, if you want to move the content of the register, so this register transfer language is used for moving the content from one register to the another register. So if you want to move the content with some condition, so we use this symbol colon here. So if I write P colon, so what this instruction will do? So this notation is used to send transfer the content of between the registers with the condition. So if p equal to 1, then only the content of the register R1, that is the information present in the R1, is moved to the R2. So then the next one is the naming of, if you want to name some operator, if you want for easy and understanding, so we use this, that is RA colon equal to R1. So if you write like this, so this will is called as a naming operator, or which is also called as to alias, to give the name to the any of the operator for easy understanding. So we can use these things. So in the today's lecture, we have seen the register. So what is register? So the register is made up of the flip flops, and the CPU whenever executes any instruction that so it will execute the instructions with the help of the registers, the information present in the register. So the complete the notation of moving the content from one register to the another register, and for all the micro operations performed is used by the notation. So that those notations we call it as a register transfer language. So register transfer it refers to the availability of the hardware of the logic circuits that are used to perform the given micro operations. So the operations performed on the registers are called as are called as micro operations. So in the register transfer language, it is basically to represent the information, represent the transfer of data from one register to the another register, or the operations performed on the registers. So we use the notation. So this complete thing concept is called as register transfer language. So that's all for the today's presentation. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.